Good afternoon, sir.
Good
Good
afternoon, sir.
afternoon, sir.
Good afternoon,
Good
sir.
afternoon, guys. Good afternoon.
Good afternoon. We have a few more people joining. I can see Shrans is there, Rashmi, Arushi, Abhideep, and then Babita has joined. Okay, good. So let's start the session. So there is no specific agenda for today's class. So what I need to know is I will anyway carry forward certain discussions which I believe is important for all of you guys. But before I start any specific concept like so let us summarize what all we have learned till date, right? We have started with basics of operating system, basics of networking, basics of virtualization and cloud, like what is cloud, how it is used, what is operating system, what are the top commands which are used in the operating system. Networking, we went little in depth. We understood the TCP/IP, OSI model, the various protocols, ARP protocol, DNS, DHCP, everything we learned, and then we try to move uh, uh, and we try to observe and experience the journey of a packet, when it leaves your computer, reaches to that server or destination and comes back. What all happens in between? The netting takes place, the routing plays a major role, right? This is all we have understood. And then we took a specialization course depending upon the track. Uh, the products were different, like Cisco, one party, then PAN, FortiGate. These were primarily the firewall companies. These are the top vendors in the world. They make the best product from the firewall perspective, right? So how it configured, how it is done. Fundamentally, they are all firewall. There is no difference between what PAN does versus Checkpoint versus FortiGate versus Cisco ASA. There is fundamentally a firewall. You receive a packet, which is called ingress and egress, right? Ingress is like when the packet is receiving. When you receive the packet, that is ingress, and then the egress is when the packet goes outside. So all these technologies, what firewalls, what we're talking about does the same thing. Like it receives the packet. There are multiple layers inside the security product through which this packet is churned. And finally, the device will decide, okay, whether they want to drop the packet or they want to process the packet. So if they decide to process the packet, they will process it one more time and send the packet egress side, the outside. Okay, so internal to external, external to internal, either way. This is how it moves. Apart from that, some of the people they learned F5, which is a load balancer technology, primarily when the packet is coming, and the most important technology for load balancing was your LTM. Correct? Primarily used for sharing the load for HTTPS protocol, because the entire, as you know, all the services, all the applications, what we do is all HTTPS based. Correct? So you connect on a server, and then there are multiple other small servers in the background. And then instead of every server interacting with the client at individual level, you bring one broker in between, and that broker will decide where to send the packet depending on the load, depending upon the configuration, depending upon some amount of setting. So this is what we have learned so far. And before taking it further, from the fundamental perspective, remember one thing, the very first question or very first fundamental concept which all of you should be aware is why this product exists. Why LTM was required at first place? What solution or what problem it is trying to address? The solution it is trying to offer, right? So think from that line. For everything which exists, switch does some job, router does some job, firewall does some job, IPS is having its own features, VPN does some job, load balancer is also required, proxy is also required, correct? Why they are required? Correct. That is the first fundamental question you have to ask yourself, and you have to be very, very clear in terms of understanding the entire ecosystem of the products. Okay. So what we will do is any topic, any specific thing which you have learned and which you think we can go on detail. If you can let me know, I can note it down. Certain things we will cover today, certain things we will cover tomorrow and day after tomorrow. I'll take a couple of sessions based on that. But before I proceed further, I want to know, maybe in the chat, maybe on the audio call, just let me know the topics where you want more discussion to happen. Okay.
Sir, can we have a discussion on PAN OS? Means basically we have learned about PAN OS, but what are the concept, means what are the basically the main questions that will we have to tackle with? Because overall
Okay.
concept firewall is very much, we know that HA or configuration or different types of configuration, ACL rules, and how to configure netting or how to configure LAN, WAN, everything. We know all that part, but what are the questions basically which will be put on to answer those related to PAN?
Okay.
Most
I'm
of
noting
the chat also it is Palo Alto, PAN,
Total questions will be asked. Okay.
ADC, Citrix ADC, load balancer, PAN, Citrix, VPN, SSL.
NAT concept, Citrix, VPN is important. Okay. Load balancer, Citrix, NAT, stateful, Zscaler, PAN, Citrix, load balancer, PAN, SSL. So in PAN, what exactly is your question? Cyber attacks on Ayush may not be relevant at this stage because, you know, they will not be asking any cyber attacks related question. If it is asking, that's just an add-on. Because we have not specific attack, we have not addressed, right? So
Sir,
let's not
in
add-on question. Yeah.
sir, basically in PAN, we were taught like how to configure things. What are the things like HA and everything we know what how to configure. But when interview asks like what are the scenario based question, like how do you host application through PAN? So like that question will be more. I think everyone should know.
Okay, so basically that comes under what are the top questions from the PAN which will come, right? Scenario based.
Yes, sir.
Scenario based PAN questions. Okay. Citrix, LTM. So in Citrix also LTM, but you guys know what the product is. That's the first question. You know what the product is, how it works.
Yes, sir.
Yes, sir.
Anyone who think we do not know what this product is? So my assumption is you know the product, you also know how to configure at a very high level. But if a question is asked in a specific scenario, right? How exactly you will be able to answer that kind of question? Is this the fair understanding?
Correct, sir. Yeah.
Yes, sir.
Okay.
So one more thing. There are many different processes which we need to configure, like zone protection, the global protect, and all. Then after netting, so we know about the process, and basically what happens is that when we configure something on GUI, we know that yes, this is the method, and we will while performing that we can configure, but verbally gets difficult to answer that these are something like we have to go step by step. So verbally to say every step is difficult rather than performing it on GUI. So is that the point we should be careful of, that we must know each and every step line by line before answering that part?
No, line by line is always best effort to use. So you don't have to by heart line by line. The way you are explaining is more important, that you are able to understand, rather than if there are 5 steps and you are able to by heart 5 and able to tell it, rather than that the top 2 or 3, how it happens. If you are able to tell, you will get more score or more chances of getting hired if you are able to explain it, because everything is just not possible for anybody to even remember it if theoretically you have not done it, right? So the idea is from the lab, whatever has been given by your trainer, you practice it and try to understand how those things have been connected and start working fine from that perspective. Okay, the how part, how it works. You know, you are configuring the VM. Okay, this is why it is required. First of all, why I'm doing it, and then how it is configured. And the third is how to troubleshoot it if you face any problem, if you are doing, where to look for, how to test basically your configuration, whether it is working fine or not. For any concept, whatever has been have been discussed with you. So what I understand is primarily from the interviewing perspective, that to also see if ask you a straightforward question, they should be able to answer straightforward question, right? But
Yes,
if
sir.
they are asking you with the scenarios, this is the situation, this is the VM and this is not working, this is working, packet is not able to reach. This is, first of all, you need to understand whether such question will be asked or not. If they are asked, how to handle it, right?
Yes, sir.
And also,
Okay.
I think Ashok, you were selling that we go to the screens and various screens to configure global properties. Somewhere some zones has been defined. Somewhere the NAT has been defined, and then we see that. Maybe I'm not. If I look at the GUI, I know how to navigate that. But if I'm asked, then I'll not remember those screens. That's probably one of the questions that he's asking.
If the question is related to that specific point where to click and all that, that is why the labs were given. And that is why whatever time you have it, you practice it as much as you can. Okay, because they will not ask you exactly where to click, what to click, where is global properties. So I said, okay, go to settings, right click, properties, and they may not be interested into like an exact flow. So long as you know where the setting is and what is done on that setting, that should be good enough, because you cannot, because unless you have done it at least 10, 20, 30 times, because nobody can remember. You understand? Because you guys have already run 3-4 technologies. So the expectation would not be to go one by one and explain how to go to that place. For that, if that question comes, your answer would be, sir, I have already done it in the lab. Some settings is available in the firewall. I'm not very sure where to click and all those things, but based on 2-3 times, whatever I have done, the settings will look like this. And this is the objective of the settings. And once you do, this is what I will be able to achieve. Is it clear?
Yes,
Yes, sir.
That should be your answer. Rather than, okay, I'm not sure, oh, click here and click there. And then they were also asking whether it is on the right side or the left side of the panel, or it is under settings, or it is under the users, or it is under miscellaneous property. That's not required. If you know it, you answer it. Otherwise, your answer would be as per the labs which I have done it. I don't remember right now. However, this is what the setting does, because they are more interested in what the setting does and what is the outcome of it. Correct? Rather than exactly telling each step by step for everything. Correct? And if you really want to be a little more confident, so whatever lab assignment has to be done, you do multiple times. And this is very obvious. When I started learning on anybody else, suppose somebody giving me a firewall, right? Cisco. I don't remember all those commands by heart, right? Sometimes I forget to enable command, en, and then you go to enable, then you type config, then you go to config terminal, and then you start typing in Cisco SA, correct? Sometimes it's a firewall also. Where is global property settings? Unless you do this exercise at least 10, 15, 20, 30 times, every time you go there, go to global properties, enable it, push the policy. Another firewall, go there, enable the properties, push the policy. When you do 30, 40 times, only then you exactly know where it is. You know exactly those properties are, which is absolutely normal. But what that property does and what is the impact, that it will be the expectation for sure if you have done it. In certain settings, certain questions, if you have not done in the lab and it has not been covered, you can always say it is not covered. But remember, if you say it is not covered, then if your colleague is able to answer it and they said it is covered, then it will backfire. So when it is not covered at all for anybody, that time you say it is not covered. But if it is covered, you say it was covered. I don't remember it. But let me try to answer this question. According to my understanding, this is how it is done. And this is what the objective is. Is it clear?
yes, sir.
Yes, sir.
Because
Yes, sir.
imagining all 4 products, see, just imagine these. See, first of all, that skill set is not at all available in the market. Who can learn 4 absolutely in depth? But the question is, if they will give you hint, like, no, what about this thing? At least you should know at a very high level whether this command is done through CLI or through web browser or both, if you have done it. Where those settings are and which portion, it cannot be absolutely wrong, right? The way you will try to answer it. But if you have not done it, don't remember it, absolutely okay to say I don't remember. But let me try to answer. This is how it is configured, and this is what the objective of this particular setting, what I'm trying to do. For example, VPN. more than how you configure the VPN, they would be more interested in how VPN works, what is the concept of the VPN, what are the fundamentals of VPN, which remain same on all products. If they still ask you, how do you configure it? So whatever you remember, you try to give it. And if you think you're not very sure, you always use that catch that, sir, I'm not very sure. I did it in the lab, but I don't remember right now. But my lab was working fine. Right? If you have successfully done it in the lab, of course, you give that confidence to the trainer that I did it in my lab and everything was working fine. I don't exactly remember this command specifically, but that I will be able to type it once I'm actually working on the product. But my lab was working fine. I was able to create VPN. Making sense?
Yes, sir.
Yes, sir.
So this is how an interviewer would expect you to approach a particular technical question. So if you know this is the product, this is why it is designed, and this is how it is configured to achieve that objective for the for the reason why the product is created at first place, then everything else is an integrity. For example, firewall is configured, VPN is configured, right? On checkpoint or NAT, netting is configured on firewall or on FortiGate or PAN or Cisco ASA. But the concept of VPN remains the same across these 4 boxes. Only where and how to configure the VPN on Cisco will be different from checkpoint. That will be different from FortiGate, and that will be different from PAN firewall. But when you say configuring VPN, that means if you know the concepts of the VPN, right? Encryption domain, gateway IP address, right? Phase 1, phase 2, what is there in phase 1, what is there in phase 2. You just have to make sure how to configure phase 1 in Cisco, how to configure phase 1 in checkpoint, how to configure phase 1 in FortiGate and PAN, and so on and so forth. There you can make a little bit mixed mistake that, okay, not here, not there, but exactly, it's a phase 1 is this is the configuration which is required.
Yes, sir. This
Is it
is the
clear?
where question comes. Yes, sir. This is where the question comes if we configure VPN in different products. So there is some or other differences which in this 1 month we can't even get to all the products in
Correct.
equally. We can't achieve that.
Correct.
So in that, will that backfire in the other way, or will it be like it's okay to be answerable? Because we know the concept of VPN, we know the phase 1, phase 2, what are the different
Concept of
modes in phase.
VPN is 80%. 80% is the concept of VPN. 20% is just how you do that. If you are able to do that answer, best in your capability, whatever you remember, because all students are different, right? It's not like few people are not able to tell that, other people will also not be able to tell. And I'm not expecting everybody will be able to answer it. Okay.
So one thing you can probably do, Ayush and the team, is that when you are configuring the VPN, suppose you are asked, how do you configure this on ASA? Okay. So you start and then, if for example, if one of the products you are very comfortable with configuring VPN, okay. For example, checkpoint. You say, sir, I have configured in all the things. Can I attempt this with checkpoint? I am confident. That's one way of doing that. Okay. Suppose you are ASA and you are not comfortable, but one of the products you are comfortable. So my idea is be that in all the 4 products or 3 products, VPN is try to be comfortable with one product. So that will completely 100% through. We will make it very comfortable for you. You can always say that, sir, I was comfortable with checkpoint. If you are asked in this, or for example, I was comfortable with Palo Alto, I configured well. Okay, sir, I can show you the steps. So then we'll be eager. Okay, you show me. Nobody will say, no, I want only on FortiGate and not on checkpoint. Okay, so that way it's solved. But 80%, as Ashok told, is the phase 1 IKE, phase 1, phase 2, and what is encrypted, how appreciate key, what is asymmetric, what is symmetric, what is client to site, what is site to site, when do you use client to site, when do you use site to site, okay, what is VPN domain, what is interesting traffic. This kind of things is absolutely expected you to be known, right?
Yes, sir.
Palo Alto. Okay, now Palo Alto, maybe we can discuss something on Palo Alto.
So now we'll go one by one. So product specific, we will take it later on. What we need to understand is the VPN concept. Then we have stateful, stateless, cloud, stateful. Two people are asking, Harshita is asking for stateful and stateless, stateful inspection. Okay, and then you have Zscaler for the interview perspective. The product specific we'll discuss. Let's start with PAN, SSL and all. Let's try to cover one by one. Okay, let's start with stateful firewall and stateless. When we say anyone who is having a fair idea that yes, this is what is stateful inspection, what is stateless, can anybody share their perspective so that I also know this is what the understanding is. If it's really good, then it is absolutely fine. Go ahead. Who would like to attempt? Anyone? This will
Yes,
be
sir,
the
I can
most
try.
important question. Most probably they will ask. Yeah, you just attempt. Let's see. Okay.
Yes, sir. Sir,
Go ahead.
basically in a stateful inspection firewall, it examines both incoming and outgoing packets. It also known as sometimes dynamic packet filtering. It
Okay.
works on layer and layer 4, whereas stateless inspection for firewall, it works on predefined set of rules that thwarts the cyber criminals. If the data packet conforms to the rules, it judged as safe and allowed to be passed through. It does not work as a machine learning or any uh, traffic classified instead of inspection. So stateless is more less reliable than stateful inspection firewalls.
Okay.
Sir,
Who
can
else
I?
will try to add more comments on top of it? You can add on more
Sir, I
comments.
would
You
like
know.
to add up.
Yeah,
Yes,
yeah,
sir.
yeah.
Like, sir, stateful.
Capture the session.
One by one. Yeah, we have a lot of things. So you keep adding your own perspective. You can repeat what Ankit has said. It's absolutely okay. Okay.
Sir,
Yes, go ahead.
stateful firewall is preferred over other
Tell
firewalls
your
because
name
it
first.
maintains. Sir, Anmol Vasist.
Yeah, Anmol. Go ahead.
Sir,
Anmol.
because it maintains a routing table. It has each and every information about source IP, destination IP, source port, destination port. Based on this, a routing table is maintained, and from that routing table, each and every entry is checked again and again. If it already existing, then ACL and all those things will be bypassed. Otherwise, not. So, because of routing table, it is known as a stateful firewall.
Mhm. Okay, Anmol. Who is next? Who will go next?
So this is Babita, probably the same thing that I would like to add up for stateful
Yeah, go
firewall.
ahead. Go ahead, Babit. Yeah, you can absolutely repeat what if you agree with certain comments. Go ahead. Yeah.
Yes, sir. So for stateful firewall, whenever there is a packet traveling from the point A to B, it hits a firewall, and if the traffic is allowed or not, it will be checked by the access list or the rules. It maintains a state table, so the firewall, it keeps a record and sends it. So whenever the packet is returning back again, so it does not check the rules, it just checks if the packet has an entry in the table, and then it allows it.
Very nice. Good.
Okay. That is called
Sir,
stateful, right?
Yes.
state
Go ahead. Go ahead.
state forward. Sir, I'm Ayush. Stateful firewall are also known as a second generation firewall.
Which one?
Stateful firewall.
Stateful is second generation. Okay. Okay. And stateless is what? First generation and third generation.
Sir, in case of stateless firewall, it's just a way of performing a firewall. Just that how that is in case of stateful that as the states are maintained and the track of connections are being maintained and the how the session analyze has been done. So basically, as these are the stateful firewall, it is configured as it perform the firewall perform accordingly. But in case of stateless, if this type of analysis and tracking is not done, then in that case we give it a name as a stateless firewall.
Okay. Next.
Yes, sir. It does not inspect the traffic. Stateless doesn't inspect the traffic. It do not even examine the entire packet, but it decides whether the policy or the rules are satisfied or not. If yes, then it will be allowed, otherwise not. No table or nothing is maintained inside stateless. No states are there.
Okay.
Sir,
Okay,
in
who is
state,
next?
sir, in Rohit, sir, sir,
Yeah,
in
Rohit, go ahead.
stateful, it will able to maintain the session, and when the particular packet sends out, it's create a session, and when getting a reply of a particular packet, it will look for a particular session and map with it. That's called the stateful. And if I talk
Okay.
about the stateless, every packet is a new packet, not able to maintain the session, and incoming and outgoing, both the times they have to do all the policy checkup.
Mhm.
So this is called stateless. Uh,
Very good.
if I if I talk about the example of a stateless, like a packet filtering,
Mhm.
that's all from my side, sir.
Very good. Very good. Anybody else?
Sir, example of a stateful firewall is ASA, checkpoint, and PIX. These are the examples of a stateful firewall.
Checkpoint and?
ASA.
Okay. What about
And
PAN and
PIX.
Fortinet?
Sir, I don't have that much idea about
PAN
that.
is
Whether
also stateful, sir.
All those are firewall are stateful firewall.
Okay.
So basically, all the new
So,
generation firewalls are the stateful firewalls.
Okay.
sir, for a faster data rate with more simplicity of operation, we should use the stateless firewall.
Okay. Now, who else would like to attempt? This I explained little bit in the midterm. Like when we are doing the interview for the midterm, right? I took one session and tried to cover this topic to a certain extent. Okay. All of you are correct to certain extent, right? But you need to understand the fundamental difference. Why, first of all, these two technologies were there, stateful and stateless, but if you go to internet, who is writing the article, from where that knowledge is coming, all are random, and the more you'll read about it, you get confused. What is written here? What is written there? Correct. So I'll give you the simplest example. At your level, you will be able to explain it. This is the whole idea of stateful. So let me see if you can see the screen. Let me share my screen. Yeah, this is most important question, by the way. Okay. There's very high chance that they will ask you when you learn firewall. The first question would be stateful versus stateless firewall. Can you see the screen?
Yes,
Yes,
sir.
sir.
Yes, sir.
So, yes, sir. A stateful firewall. Okay. This concept was actually launched by a company called Checkpoint. They claim that they are the first company in the world to create this concept of stateful firewalls. It's a patented technology. Correct? I think it 90s, I guess 94 or 95. This company, created this technology. So since it's the old technology, common sense says that all new companies today, PAN, Cisco, Fortinet, and all other companies like Zscaler also to a certain extent, like there's a cloud-based firewall, right? They all use this stateful concept. For example, firewall is a very simple concept. What is the concept of firewall? You receive a packet, there is a rule, apply it, drop the packet, accept the packet, move forward. This is firewall, correct? Now this concept, which I explained to you in a plain English, if you go to the deep packet inspection, next generation firewall, third generation, fourth generation, so people will keep using different kind of terms to arrive at certain kind of skills or topic or a point, but the fundamental concept of stateful remains the same. If you understand that logic, then top of it everything else will be built, whatever you are trying to read, and then see whether it is making sense or not. Is it clear? So the first thing first, stateful inspection is little older kind of concept. Still people are trying to evolve from it. PAN is a company which says that like we are doing next generation firewall because we are adding users, IP and everything else. But at the core level, the concept is stateful. And why this was launched? It was launched before stateful. All the other firewalls were stateless. Stateless means no idea about communication. Right? No idea about the communication going on. So let us understand this idea with a diagram. So you have a source, you have a firewall, right? And you have a destination server. And you want to open the protocol called HTTP. Understand the story. So 1990s, HTTPS was not there. Everybody is HTTP. You are a source here. You have an IP address 10.10.10.1. Okay, and the server is public IP address like 20.20.20.20. You want to open this HTTP connection. Your packet starts from here. This is your source. You want to go here to the destination, correct? The packet which leaves this NIC card. What will be the source IP address on this NIC card? Tell me. What will be the source IP address of the packet which leaves the NIC card, the Ethernet card of this particular source? What will be the source? 10.10.10.1 is a source, right? What will be the destination? 20.20.20.20. What will be the source port? Source port number.
Any. It will be.
It could be
random.
any random by operating system. Operating system will assign some random number. It will always be more than 1024 number. So it will always be 1025 and above. Generally, it is like in 5500 like this, such big number. The maximum number it can go is 655, 35. 2 raised to power 8. If you add, this is the number you will get. OK. Now, any number you will be able to assign by the operating system. What will be the destination port in this example?
80.
Port is 80. And then protocol, application layer protocol.
HTTP
is a TCP. Sorry, transport layer is HTTP is an application layer protocol. At transport it is TCP, right? Source IP, destination IP, source port, destination port, and the protocol. this packet leaves it and it hits here inside interface. Okay. Now in the firewall, you have a lot of rules created. Okay. A rule number or access list, rule number 1, rule number 2, rule number 3, right? You go one by one. It starts from top, go to the second, go to the third. In rule, what do you configure? You configure source IP, destination IP, you configure port, sometimes you configure zone, depending upon what product you are using, and then you configure whether to accept the packet or drop the packet. Is it clear? Any doubts here?
No, sir.
So the packet hits the firewall where it will start looking at this rule. Shall it start with the last rule, random rule, top rule? Generally it starts at the top.
So it goes sequentially from top.
Okay, it goes sequentially from top to bottom, the way you have configured it. If your rule, top rule says any source, any destination allow, so irrespective what you are typing in below, it will not matter. Similarly in access list, if the access list top rule says allow, then there is no point of configuring drop, right? So it will check this rule. It will check source port 10.10.1. Suppose the rule says 10.20.30.x is allowed to 20.20.30.x on port 80, and you say allow. So this packet is coming to the firewall. Will it match this rule? Yes or no?
Yes, sir.
This packet 10.10.10.1 2020 will it match this rule which says 10.20.30.x trying to go to 20.20.30.x?
No, sir.
It will not
No,
match.
sir.
10.20.30 is different than 10.10.10. Correct? If it is a network 10/8 10.0.0.0, then it will match because it belongs to the same network. Is it clear?
Yeah.
But here it will not match. Source is not matching, destination is not matching. Since it is not matching, it will check the rule number 2. Rule number 2 says 10.10.10.1 and destination is 20.20.30.x, port number 80. Will it match the second one?
Yes, sir.
No, sir.
No, sir.
It will not match because 10.10.10.1, 10.10.10.1, okay. But destination is 20.20.20.20. Here it's 20.20.30. It will not match. Correct. In order for a rule to match, it has to match the source IP, destination IP, port. We have not reached till port. One of the things is not matching. So if it is not matching, whatever is written here, I don't care. I go to rule number 3 or rule number 4, whatever, right? This rule says 10.10.10.1 trying to reach 20.20.20.20 port number SSH 22 allow. Will it match?
No, sir.
No, sir.
Why?
The
Port number
different
different.
number.
This matches,
Port.
but this is not matching. Then it go to the next rule. This is 10.10.10.1 20.20.20.20 port 80. Here it says allow. Will it match?
Yes, sir.
Yeah.
Now it
Yes,
will
sir.
match. Okay. Once this packet is matched inside the firewall, right? Ingress, when the packet is received, you are processing this. Now you have to release the packet to the external interface, correct? Here, you have to release the packet. Before you release the packet on the external interface, do you think as is I should release the packet or I should modify something in this packet? Tell me.
Now it acts as a source, sir.
What?
Now destination act as a source.
Destination No. I'm asking packet is still, it has received here, processed. Now the packet has to leave the firewall for the next device till the destination part. At this stage, when it has to just release the packet, will it modify this packet, which looks like this? Will it modify? Yes or no?
No, sir. No, sir.
It will not modify.
Netting is not done, sir.
Netting will be there.
In the real world, whatever you have studied, it will modify the source IP address because this is a private IP address. Any private IP address, if it is internet, assuming we are accessing Google, and if netting is mandatory because with this source IP 10.10.10.1, you may be able to reach the destination, but reverse packet will never come because it's a private IP address. So what your device will do is it will change this source to a public IP address, which is generally in the firewall is the external interface IP address of this box generally. But sometimes it can be other also because the job of this firewall is also to apply rule plus NAT. Both it will apply. So this particular IP address, okay, is converted with the external IP address of this box. Okay, because this side in LAN, which is local. This is WAN, which is public. But sometimes when you are working in BT, you may come across many firewalls where the LAN side, WAN side, both are private. Because this firewall is connected via some cable to an external router, and router is actually connected to ISP, to the internet. So here is public. For firewall, LAN is internal, WAN is also internal. So concept of netting, though it says private to public, but it can be applied on public to public, private to private, does not matter. The objective of netting concept is before I release the packet, shall I change the IP address, source or destination or not? That's the question it will ask. If the configuration is done that yes, you should apply, then it will go ahead and do that. Why it will apply? Because this is private IP. So this will be changed to public. Suppose the public IP, keep it in simple network. Suppose this is also in 20 network. So this will convert into 20.20.20.1. Everything else remains the same. Second thing it will change is this source port. So it is creating a NAT table. This table is called NAT table, right? This is before and this is after. Before my packet look like 10 is the source, 20 is the destination. OS, whatever has given you the port 80 TCP is my before. And after it will change it to this IP. This will remain the same. This will be some randomly generated source port by the firewall stored here. And then this packet will be released on the cable, physical cable to the destination. This is how the packet will reach the destination. And when the return packet is coming, okay, when the return packet is coming, again, it has to go through all the rules. Those days, there were no rules. There were access list on router. Since these devices don't hold any data, the packet will come. Again, it has to go through the same process. What is the rule number 1, rule number 2, rule number 3? You know, and the packet will be accepted. Somebody will argue that yes, then data is already there in the NAT, so packet will hit it and I will be able to accept the packet and will be able to move on. And this particular requirement of storing this information while going the forward and coming it back was the major reason why firewalls are not scaling. Network layer device were only able to look at the IP addresses, and the application layer, which is looking deep inside, whether you are sending a PDF, whether you are sending Word document, whether you are sending a malware, you are writing a script, which is always there on the application layer, visibility, you'll not be able to scale it. So Checkpoint as a company came up with the concept to solve the speed of this issue, that every time I'm going, I'm checking the rules, coming back, I'm checking the rules, and very difficult to create products which will match both the rules, both the sides. This checking the rule base every time. Okay, when the packet is coming is generally called stateless. Stateful firewall is along with this NAT table, which is a mandatory. Suppose there is a firewall where NATing is not required, so this table will not be there. You create another table which is called state table. And that is the word state table is the reason why this firewall is called stateful. So what Checkpoint told is that let us maintain this communication inside the RAM. And what will be maintained? First packet hits the firewall, check all the rule base. Once the packet is allowed, you made an entry here. For you from the interview perspective, just keep it simple. Don't go too in depth. You keep at least these mandatory information: source IP, destination IP, source port, destination port, and protocol. These 5 entries you keep it in the table. And keep it. There is a timer for all these connections. Whatever connection I have added it here, there is a timer in the RAM. It's a 60 seconds or 60 minutes. This will be different from different firewall. Cisco may have it 60 seconds, PAN will have 60 minutes, does not matter. One entry is made, there is a life of this entry. So what happens? First packet for your computer reaches the firewall. Firewall check all the rules, process it. Once it allows the packet, an entry is made inside the state table, which is stored in the RAM. So there is a command available on all these products to check the state table. I can demo you on Checkpoint. I'll show you how to check the state table of my Checkpoint firewall. How does it look like? Similarly, you should be able to check state table of FortiGate PAN. I will check and I can let you know by tomorrow as well. We'll be able to see the state table. Now, what is the advantage of this state table? Entry is made here. In stateless, the issue was when the packet is coming, again, I have to go through all these rules. So I have to create 2 rules, forward and backward, both. If any change in the source and destination port, like FTP protocol, it works on 2 ports, 21, 20 and 21. 20 is generally started at the server level. At server, you start with 20 and come back to the client. Now rule says 21 is allowed. You are coming from 20. Obviously, this firewall will not work, the stateless firewall. But in stateful, the way it is designed, it understands it both are same. For FTP, for HTTP, it is 443 HTTPS. For HTTP is port 80. These entries are made in state table. When the packet is coming back from the server, it will not check this rule base. Because these rule base, which I gave you the example earlier also, in one of the banks where I've seen it, 15,000 rules were there. Any packet which is going forward, coming back, looking at all these 15,000 or 13,499, it matches the rule. Backward and frontwise, when the packet is reaching, it is always difficult, correct? You will never do that because these entries are made inside the state table. That is why it is called stateful. And when the return packet is coming, it will match the entries inside this table. And these entries, it is one entry for one firewall. When these entries are made 1 million, 10 million, these connections are called concurrent connections. And you will see on the internet, people will sell their product saying that my firewall supports 10 million concurrent connections. Literally, they are saying that my RAM on my firewall can have 10 million these entries. If it is more than that, the CPU RAM utilization already 100%. I will not be able to handle it. Software wise, it can go 100 million also. You don't need any change. We're talking about the entry inside the state table. When the packet comes, it matches the RAM. Since it is in the RAM, it doesn't have to check in the rule base. It is much faster. And it need not have to go through the rule. Why? Because you have already allowed the packet. Why to check it the return packet? Why you should check? There is no need to check the packet, right? If the firewall says it is allowed, return packet should also be okay. It checks the RAM, not the table. And this table is called state table. You will see all these entries. There is a life of these entries in the state table. It keeps coming like no, like in any company, you have 10,000 employees. Somebody's coming in morning shift, night shift, afternoon shift. You open some website connection, it will be there for a few minutes. It will go out. As an end user sitting here, you have no idea what all these things are happening in the background. And you should not care also, because for you, microsecond, you will find a difference. Not even that. Because the delay is not in the firewall level. Delay will be at the ISP level. If at all there is a delay, because connectivity from your computer, your Wi-Fi to your router is all how much? 100 Mbps, more than that, right? Connectivity here is very good. The bad connectivity happens at the internet level. So you will never see this. All these things are happening in the firewall end. This concept of receiving the first packet, analyzing it, and putting a state table entry inside the firewall for a few seconds, depending upon what is the default setting of a particular product, and matching the return packet on this connection table rather than on checking at the rule base. This concept is called stateful. Why? Because the CPU cycles required to check a rule base versus CPU cycle required to check the connection table. This is very fast because you may have 15,000 connections, right? But not all rules are hit at the same time. Some rules are not in use. Some are less used. And that is one of the reasons a lot of time on firewall, optimization, customer says that the top utilized rules, highly utilized rules, that should be kept on the top or it should be at the bottom.
Top, sir.
Top, sir. Top.
It should be on the top. The order of the rule matters.
Yes, sir.
Yes, sir, as it is sequential.
Correct. It checks on the sequential part. Some vendor says that it only matters once. And once the data is there, we also bifurcate inside the zone wise. And then when the return packet comes, we take care of that. So that's a different part. But you also believe we're talking about the first packet. First packet is received by firewall. You have written 10,000 rules. It has to start somewhere, right? That is why you have rule number. Some firewall would say they will look at the zone. If you have divided certain rules in certain zone, then they will pick up the zone part first, and inside the zone they will look at the other rules. But this is absolutely, don't go into that definition of this stateful. You keep it simple as a fresher level, entry level. This is what you need to understand, that stateful firewall is nothing but a concept where the entries are stored in the RAM based on the initial packet inspection of the firewall. Once it is approved, entry is made in the state table. When the packet is coming back, rather than checking the rule base again, it is stored in the RAM and then the data is matched inside the table and the packet is quickly processed. Some people in some documentation where the complex explanation is given, they say that stateful means you will also check the deeply all those packet what you are trying to send. But that is not true, because you still create this connection once, but if you are sending suppose a PDF packet, right? So you will create a TCP packet, TCP sync. All of you guys know three-way handshake?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Correct. You know a three-way handshake, correct? So once any TCP connection will have a three-way handshake, and once it is done, I'm just trying to. So what some of the products will tell that there is a user here. Suppose you want to transfer a PDF file via email or via FTP or via SSH or whatever, right? And then there is this device, next generation firewall, and it goes to the internet. At the stateful level concept, when the packet reaches and you want to upload the data on the server. OK. And this is a malicious file. Or the reverse, you take there is a malicious user here. That will be much more easier, right? Bad user are trying to upload a file on via this firewall to a server which is hosted internally. This is your server. You want to protect this by a bad user, or you have a bad internal user trying to send some bad data via this firewall. So some of the documents will also talk about the same concept, stateful, what we have agreed. However, when the connection is established and when you're trying to send the PDF, this firewall is also configured with deep packet inspection concept, which is an IPS. It will open up every data what you're trying to send, and it will matches the signature, or it will send the logic to the cloud, its own private cloud, and ask the question, is this PDF good file or bad file? So it is doing so much of work apart from additional stuff, whether it's allowed, not allowed. Maybe firewall rule says allowed because firewall rule says source IP, destination IP, source network, destination network, whatever, port and allowed or not. It doesn't say anything else. There is no firewall rule which says it allows, but bad PDFs are not allowed. That configuration is called the deep packet inspection, intrusion prevention. Some companies will call threat prevention. These are different words which is given depending on which product you are using. But if it does this and decides that yes, the packet is bad, right? So what it will do, it will block that connection which you have allowed in the rule. In rule it says source IP, destination IP, port and allow. Port says that HTTPS or HTTP and some file I'm trying to upload 20.20. Same example, let's keep it 10.10.10.1. You are allowed HTTP access, but inside that HTTP you are uploading a malicious file. So the moment this device is configured to look inside the packet, right, it will block it, and it will also remove the entry from the state table. This entry is gone. It will never maintain this entry here. Some definitions say that it can look into packet deep and all. Why? Because most of these firewalls which is coming in the market nowadays can do all this stuff, which was not possible in the initial level of firewalls, but used to, getting developed 20 years, 15 years back. They were already filtering the packet on source IP, destination IP, port. These are the three most component which were required to block or accept the traffic. This feature of blocking at port level is called firewall. In actual sense, this is firewall. That's it. When you look inside, what all files you are transferring it, PDF, Word document, script, that concept is called intrusion prevention system. That another product was launched. So 25 years back, this was the only product in the market. There was no other product. You can only do this, what I'm showing you. Source IP, destination IP, port, allow or block. That's called firewall. After that, another product called IPS came into picture, which will look inside the packet. See, you are allowed to access the website, but inside the website, you cannot upload inside that connection. You cannot upload PDF or virus or anything like incoming or outgoing both. That can be handled only by a product called IPS, intrusion prevention system. Now this got many names. Threat prevention, for example. Now what is threat prevention? Is basically it's a new name, but what it does, it will look deep inside the packet and check whether it is allowed or not allowed, rather than checking on the port level. Now people will combine these three stuff and call it as this also a stateful. Which is true in that sense that any packet is getting dropped, connection will not be put in the state table. But the stateful firewall is basically means that your connections are stored inside a connection table. There is a command to check into that. When the reverse packet comes, it need not have to check the rule table, and then everything is fast and you are not compromising the security at all. Now somebody will ask a question that you have this user, you have this server inside your company, and both are connected to firewall. Okay, and then this is connected to the internet. There is a malicious user here, bad user, who knows that firewall will have this entry in the connection table, right? And when I'm stating a packet, what I will do is, for some strange reason, I know the IP address of this firewall, that this firewall has tried to connect a server. Okay. So this entry inside the firewall table, source IP. This is the destination IP of the server. So entry is already there. Source IP, destination IP, source port, destination port, right? And protocol. These 5 entries are already there for this machine. There is a bad user who will try to reach the server by specially crafting a packet which will match this entry. As a malicious user, at least for sending the packet, you will be able to create a packet with source IP looks like this IP, as if it's a return packet. So forward packet is allowed, entry is made, now the return packet is coming in. Rather than return packet coming from the server, it comes from here. So if the packet comes from here, from the same entries, whatever is available, right? So we know if it is a TCP connection, what is the first packet?
Sync.
Whenever you start a TCP, what is the first packet?
Sync.
You will always have a sync packet. There is no data, nothing. Just the sync flag is made 1. One flag, 1 bit is made 0 to 1. What is the return packet?
Acknowledgement.
And then what is the third one?
Acknowledgement.
These 3 packets are first transferred. Then the 4th packet is your actual data. Okay. Now we know that any TCP connection always starts like this. And when the packet comes from a hacker, and hacker says, I'm sending this sync packet. When the hacker sends sync packet, it checks the rule base because it's the first packet. However, hacker is trying to copy this reply packet. So it will send syncAC or any 4th packet, 5th packet, whatever data packet. When such packet comes, it will check the state table. But for some reason, even if it matches everything, this flag is coming from outside, right? The packet is coming from outside. Correct. And this packet says I am acknowledgement of some previous packet. This firewall will reject such connection and the error message will be out of state. Why? Because I never send any data with the sync. So you never send. There is no entry in the connection firewall. How can the first packet be acknowledgement for any packet to start with? I will never check any rule base. I first receive the packet, check if it is a TCP, I'll check with syncAC or not. Forget about rule base. I'm checking at the very header level. If the header says acknowledgement, if it is acknowledgement, that means the entry has to be there in the connection table. You guys agree?
Yes, sir.
Yes, sir.
If it is acknowledgement, means it is the second packet, third or fourth packet. It is not a first packet. If it is not a first packet, that means the entry has to be there in connection table. So I am not going to check my 10,000 rule base or 5,000 or 300 rule base. I'll just check this logic, whether the first packet what you are sending me is sync or not. If it is anything else, I will simply reject it and telling it out of state. So how you are safeguarded? You did not even check the rule base at all. Why? Because you have a concept called stateful firewall implemented on your device. So rather than checking every time every packet, looking at the very first packet properties, you can take a call whether to check the rule base or whether to check the connection table. If it is awkward packet, right? If it is acknowledgement, I will check connection table. If it is not acknowledgement, I will check the rule base. But before I check the rule base, it has to be a sync packet. If stateless firewall was there, every such packet with acknowledgement also will be received by the server. It will not block because firewall has no idea. Rule says that this server, this destination is allowed. If it is allowed, packet is also allowed. Is this concept clear now? I'm not getting into what happens at ICMP packet, what happens in UDP, which doesn't have these things. That will be out of scope at this stage. OK, so focus mostly on the sync part because it's easy to explain people. But to tell them that this is what I have learned. Is it clear now? Stateless and stateful concept.
Yes, sir.
Yes, sir.
So you're not going to forget again? Because it's the most important question. And if this is where you are struggling, then there is something wrong. If you read some random content on the internet, they will always be confusing. Just hold on, because that is what I'm telling where you are acquiring the knowledge and how exactly you are acquiring the knowledge. OK, so let me share the screen with you. You guys can see the screen.
Yes, sir.
Yes, sir.
Yes, sir.
So look at the definition of stateful and stateless on a company called FortiGate. FortiGate is a top company. Look at the way they are explaining everything. Totally confusing. Stateful firewall inspects everything inside the data packet. I told you, right? If you are running IPS feature, why they are giving this definition? Because Fortinet was one of the first companies to integrate everything in a single box. And now they have changed this definition, right? So everything inside the packet, the characteristics of the data, channels of communication. These are all English. What do you mean by channels of communication? Anybody reading it, like, no, you'll get more confused than the actual definition. Stateful firewalls examine the behavior of a data. What do you mean by behavior of a data packet? And anything seems off, they can filter out the suspicious data, which I told you, right? If you are running an intrusion prevention feature also, if you are running threat prevention feature, after the firewall allows it, it goes deep packet inspection. If it finds something wrong, you will block it. So what Fortinet is telling is the most recent advancement in cybersecurity, where all the security is running on the same box and collecting it and putting it together and calling it. This is the definition of a stateful concept. OK, stateless in a different fashion. However, you go to Checkpoint website. You read whatever I told you. It's plain and simple. When the connection is made, state is said to be established, and end of the connection, the client server will tear on and will send a FIN packet, and connection changes the state from established, right? There is a protocol called stateless also, UDP. UDP don't have a, sync and all. Whether the packet is coming from source to destination or destination to source, there is no way we'll be able to understand it because there's no sync kind of concept, right? It's just a data. The very first UDP packet will have a query that this is my domain, please tell me the IP. The very first packet. But if it is a TCP based DNS query, suppose if it exists, because DNS also works on TCP and UDP both, it will first send sync packet, sync acknowledgement, and fourth packet will be tell me the IP address of this name. I'll send you the link for both, right? It explains certain things, right? How it comes, performance scalable. What are the advantages? These two are important, that it is effective and scalable. So equally important that from where what we're trying to understand. Now, both are not talking the same thing, right? You read the explanation, you will find so much of difference in between. Okay. All definitions could be right. I'm not saying that no, what is right or wrong, but the way you have to understand and explain it, what I have told you, if that makes sense, you go ahead and explain in that fashion. That is how it was born, right? Checkpoint, created it. Don't say they. I told it because I worked in Checkpoint, but don't use that word. Checkpoint created it because some vendors who are a fan of PAN or Cisco, they will say if you tell them that Checkpoint invented it, they may get offended and they may not like it. Don't use that word. You tell them like no, but it's on the internet. If you go, you will find out like no, there's a patent on Checkpoint name, but you should be able to tell this is why stateful means and stateless means it maintains the table. Table is there in the RAM. When the packet comes, depending upon if it is a TCP packet, if it is anything other than sync, then it will check whether in the connection table the entry is there. Why? Because firewall, it's a stateful firewall. It knows if it's an acknowledgement packet, then there must be a sync already gone. And since already gone, that means entry has to be there. If entry is not there, that means either the packet is dropped. Once the packet is dropped, there is no connection entry formed, right? You guys okay? When the firewall drops the packet, there is no entry made in the firewall. Is it clear?
Yes, sir.
Yes, sir.
So when the packet comes back and it is not sync packet, right? So suppose an acknowledgement packet, firewall knows that if it is acknowledgement, there must be a sync earlier. And since there must be sync earlier, entry has to be there in the state table. And if entry has to be there, let me check directly inside the entry table. If there is no entry found and this packet says I'm acknowledgement, you release an error message saying that out of state packet, drop the packet. Drop it. This means that if the firewall is already have been dropping such kind of packets. No need to process it. Or when the entry is there, matches it and process it and keep removing these entries at the lifetime, like 60 seconds, 5 minutes. Generally, it is 5 minutes for TCP, right? TCP connection 5 minutes there in the state table and removing it. So that is why you will see the RAM utilization going up and down for the state table configuration. RAM is not only state because firewall is also processing a lot of things, but it will have little impact on the table as well. Any questions? Before I answer, Josna Bhai, she's asking packet filter and stateful. This is clear. All of you will be able to answer this. Now
Yes,
your
sir.
job.
Yes, sir.
Your job is to go and check your firewall on which you have worked. Where is my state table? What is there inside the state table? Go and check. And the more you do, you give the same example in the interview. Sir, I logged into Cisco ASA and this is the command to check the state table and entries will be formed. Initially, you will say there is no much connection table entries will be there. When you ask a client to access a browser or access the destination, new connection entries will be formed inside that. Okay. Yes, related to this topic, anybody, any other question which you want to ask, suggest, participate in the discussion so that it is absolutely clear to all of you guys. Guys, is it clear first of all?
Sir, can you explain the sir?
Yeah, go ahead.
Sir, can you explain the 2-tier and the 3-tier architecture of the firewall?
Come again.
Sir, the difference between what are the 2 tiers and the 3 tiers of architecture of firewall?
Okay, so 2-tier architecture, but let's hold this for a moment. If anybody is having any question that packet filter, and I will go one by one. If you have any suggestion, we can go to 2-tier and 3-tier. I'll explain you. I'll show you the demo itself. Let me share the screen because I was just connecting my VPN to show you this table. Can you guys see the screen?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So okay, so I'm on standby firewall. Let me log into the active firewall. So this is the command on checkpoint to find out how many entries are there inside my state table, connection table, basically. They say connection table, so they're telling right now I have 1486 connections, but the highest till date is 27,000 connections. If you want to see what is inside that, let me type -f. Now it is taking out the data and going to display that output on the screen, whatever the connections are there. Okay. So look at this, the entries, time, source IP, log ID, some context is there. What is the direction of this packet? Whether 0 means inside to outside, 1 is outside to inside. What was the source? There's some IP address. What was the source port? 53. So that means a return packet because there's a DNS. 53 is what port? DNS, right?
DNS query. Yeah.
Yes, sir.
Right. It is trying to reach 14.1. What is the protocol? It's a UDP protocol. Direction is 1. 1 means outside to inside. So all these entries are there in this connection table. So whatever you guys will do, this connection table entries will be formed. It is not like immediately you'll be able to know that. So all this packet, what we are talking about, text. Let me, in the Linux, there is a command, right? I mean, you can do this greater than and the file name. So whatever was the output of this command, this output, everything will be saved inside this file so that we don't have to run every time. Okay, and then we will see inside what all the information is there. And it's a big command. So depending upon different product, they will give you different command to look into the connection table or state table. There will be a NAT table also. There are a lot of tables which are there in the kernel of a particular product, and then you will be able to do that. You don't go till this understanding, whatever I've told you, but that should be good enough. That stateful and stateless means you are not maintaining the state of the communication and you are treating every packet as unique. Inside to outside, outside to go through the rule-based process, everything you are checking every time. But stateful firewall was designed to take care of the communication part because the state table was getting created rather than checking all the rule base. Now the table will be checked. Return packet is automatically taken care of. We don't have to worry about it because if the protocol is FTP, so it will automatically create two entries in the state table, 20 and 21 both. And when the return packet is coming, it allows for both because it's no FTP is a good protocol where it works on both the port numbers. And if anything else is coming, for the TCP, which I gave you the example, rather than checking the rule base, you first check whether it's an acknowledgement packet. Acknowledgement means it's try to be there in a state table. It's not there, drop it. Drop the packet. You don't need to check the rule base. Correct? So you can search. Let me see if I can check my IP. (16.10.60). Some of the connections, as you can see here, people, those who are connected, who are passing through this firewall, I am able to see. This is the destination IP address of my network. When I connected on the VPN, this is my IP, and I can see these are the state table. This is the IP, this is the destination port. It's a TCP. It's a 443. Obviously, it is a return packet because destination is private. Sorry, this is coming from 12 and 11. Both are private. It's a VPN packet. Clear, guys?
Yes, sir.
Okay. Now your job is to check the table in the other firewall product as well. Okay. Yeah, let's go one by one. 2-tier, 3-tier architecture. Let me open up a diagram for you guys. But this is the conceptual level. I don't know why they will. I don't think so. They will ask this question. But just in case, since you have asked, 2-tier firewall, 3-tier is basically in a very small company. You have one firewall. You buy one firewall. You have one router if required. Otherwise, you have one switch. And everybody is connected on this switch. 50 employees, 100 employees, more than enough. Everybody connect to the switch or few switches. And then you are running in between the STP. I hope you guys are clear. Like, no, these revision sessions are over, correct?
Yes, sir.
Spanning tree and all, right, to take care of that. So you have these many users going to the firewall, and via internet, you access whatever server you want to access. One firewall, it maintains both sides of communication. Inside to outside, outside to inside. But if these machines are compromised, because these are all users, they are accessing websites in and out, private work, personal work, they're trying to, store some data and everything else, right? These machines can get impacted if you have one layer of firewall. One layer of firewall is generally used in small companies who do not have anything very significant inside their own infrastructure. Here they don't have much to defend. Only users are there. You are using laptop to access the internet. Okay. Is it clear? Small company, you need one firewall. You don't need more than that. But suppose you are the same user on the internet here. Now you are trying to access a bank's website, ICICI, for example, their bank's infrastructure, or any bank, ABCD bank. What happens? Packet is received by the firewall, for example, on TMZ zone, because this is your net banking. Everybody connects from outside this DMZ. ICI bank's most critical data or database servers, core banking servers. This is their lifeline. Okay. Unlike this small company which is trying to protect the user, if it is compromised, it's fine, okay, not okay. Imagine a bank which is not only about this bank which is having 50,000 employees, but it is also about users or the customers of this bank, which could be ranging from 50 million. If anything happens here, this core banking or some database server, which is very, very crucial to the company, the entire company will be impacted, so many users will be impacted. So what happens is as a design mechanism, when you have such critical information, and these websites never talk to internet directly, not required. They are not accessing Facebook, Google, Microsoft. They're not doing this. This is not their job of the servers. They are just sitting and controlling the most important data. User is going to internet because that's required. They're the employees. They're sending email, receiving email. They're doing all kind of stuff. But this is the core data which is hosted in your infrastructure. If you want to access this particular data, you want to protect this data, this concept of two-layer firewall has come up. So you will create one more firewall here. So there are two firewall to firewall, and this firewall will protect this information. And this firewall will also go and sit here in internal users. The employee of the bank will be sitting here via this firewall. They go here, go to the internet if they want to browse the internet. If a user, net banking user comes here, access the DMZ, from this, it goes to this firewall, and this will have rules. Who all is required access to this most critical database server? Very, very critical firewall here. Any changes on this firewall is very, very critical, very critical. Here it's fine because going out users, everybody's there. The designing of these two layers to protect the database server, core banking, or most crucial, and you do not have to be core banking. Any customer can design this architecture and safeguard their internal interface, because any changes, suppose you made a mistake here in this firewall and you allowed SSH from outside by mistake, because in this server you're troubleshooting. This employee went to home and they said, okay, I work from home, so I need SSH access directly. They opened a firewall and they allowed SSH here. Suppose if this is not there, imagine this firewall is not there. What will happen? Can you go on mute? What will happen if this is not there? Then what? This mistake of opening this port will also hamper your core banking, which is your core database, which can lead to different kind of issues altogether. Very crucial. So most of the big companies will deploy two layers of firewall. So this is protected separately, and this is protected separately. This is generally used for accessing the DMZ machines, which is hosted for public. DMZ means public. These servers are for the people. It's called DMZ, demilitarized zone, because it's a business like Flipkart, Amazon, Times of India, IRCTC. What is their job? Their job is let people come and access my website. If this is your job, you are inviting hackers also to access it. So you keep all these machines into a separate zone, which is generally called as DMZ. It's just a name. It is nothing. It's just a fancy name given to segregate your servers, which you are hosting in your office for the external consumption. So that since you are hosting, it's your job, it's your business. You are inviting thousands of people to come and visit your website. You are doing advertisement. Hackers, good people, bad people, ugly people will hit this machine. And somebody will be able to target it, compromise it. If this is compromised, then if you keep it inside the LAN, suppose the server is inside the LAN, then once this is compromised, everybody else will be compromised. But if it is in this zone, then in order to spread the attack from here to here, one rule is required. Suppose this rule says this firewall or this web server cannot go inside. It can only go outside. Then you are still safe. This is compromise is fine. Attack will not spread because of this DMZ concept. But if it is compromised, rule is also bad, then obviously nobody can protect in the world, right? But this idea was developed to achieve this objective, that some servers which requires public access should not be kept along with my private users. So if I have a firewall, I should not keep my users who keep downloading that stuff, sending the data, processing it all the time. There's a high chances that they may get also compromised, whatever. But nobody from directly can access these users, right? Because they are hidden behind hide net or dynamic net. So they go outside. Outside people cannot come to them. So they are pretty much protected from that unless they themselves go to a malicious website and download something bad. Hacker cannot access this machine directly. But if this is your website, you are telling the world to connect to you. The hackers can also connect. Your port 80 is open or 443 is open. If you keep both next to each other, if this is compromised, right, it can impact other machines also. Because there is no firewall in between. Now there's no firewall between this and this and this, right? It will spread. But if you put your server onto another port, this is another port, this is one port. So DMZ is just a name. It can be ETH0 or it could be port 1. This could be port 2. So there is nothing called DMZ kind of. This is just a concept. Concept of DMZ says you put machine which you want public to access. Public is sitting here. You want the server to be available to them. So public will come like this, firewall, access this port. Even if they compromise this machine, in order to spread, it has to go via firewall. And unless there is a mistake in the firewall, which you are allowing packet inside from DMZ to this to all the users, only then they will also be impacted. Otherwise, you are safe. This concept is called DMZ concept. And this two-layer firewall architecture, which I told you, big companies will always have second layer of firewall, first layer of firewall. In a technical term, if you really want to remember and by heart it, the firewall which is facing the internet. OK. Internet facing firewall is called perimeter firewall. Because it is connected to the internet and all the DMZ. So DMZ should be created on perimeter firewall or DMZ should be created on core firewall. Tell me.
Perimeter.
Perimeter.
Correct. Answer is perimeter. Internet. I am exposed to the internet. I want this website to be public. I'll keep it here. Internal firewall is called core firewall. OK. So these are all the linguistic, the language which people will generally use. Core firewall they use. What do you mean by core firewall? It's the internal firewall, which is more critical. If this is down for suppose 10 minutes and there is an escalation till CEO, if this is down for 10 seconds, there will be escalation to CEO. OK. Is it clear, guys?
Yes, sir. Yes, sir.
The question would be in which situation you should use one firewall, two firewall. What will be your answer? So the person who asked this question, can you answer it? In which situation we should use or prefer one firewall, two firewall? Josna Mai.
Sir, no.
No, my question is, how do you define what will be your logic that in this situation I should do one firewall? And this case I will use two firewalls. One layer, two layer firewall, right? No, but no,
Sir,
sorry,
if
Josna,
we
that was
are
not the
having
question.
one interface,
You go ahead, but you can answer it. Yeah, go ahead.
sir, if we are having one interface, then we can use one tier firewall, and if we are using DMZ zone, then we can use two tier firewall.
So basically, it
That's
will
not the
depend
actual
upon the
answer.
organization. If the
Yes.
organization do not want to expose its critical data, then it will apply. It will put a core firewall and the user details in that, and the other things apart from that, which organization want to access for every people, for the people, it will put in the DMG zone, and there
Correct.
we
So
will put firewall for DMG zone based on defined rules, so that everyone can access that.
correct. So the answer would be that if you have some servers which are very, very critical, which should not be exposed to the internet, but still required in your company, and security says that it has to be protected well, then I will create two layers of firewall. One is to protect that core servers. At the same time, I also have some server which has to be hosted for the internet, where people will access it from outside. That servers, I'll keep it in the DMZ zone of a perimeter firewall. So I will create two firewall. One is for perimeter, another for core. Behind core, I will keep all my critical servers, and in the DMZ zone of a perimeter firewall, I'll keep my external server. I'll manage the policies differently on these two machines because requirement is different. Correct? External user should not access my core servers directly. Is it clear?
Yes, sir.
So this is the way you have to answer it. If the question is in which situation you should do one firewall, two firewall. If that is what I generally, I don't know whether they'll ask or not, but if the situation is coming to that, discussion, that is the way you have to handle it. That core firewall is designed to protect the most crucial servers, which should not be accessible to everybody, including employees. Not all employees need access to core server. Do you think the ICICI employee sitting in the ICICI bank can access the core banking directly? The answer is no. Correct? So you first filter the packet at the perimeter level for the outside people. Internal also, if you want to give the protection, you put core firewall. Now the very common sense kind of question. Is it mandatory to have a very core kind of servers to have two-layer architecture? Is it mandatory? Suppose if I'm a company, I have a lot of servers. So unless it is very, very core and all, then only I should have two-layer architecture, or I can still create it. It's a common sense question. What do you think?
So it will depends totally on the organization need what they want.
Absolutely. This is a concept. Nobody can stop me. In my PurpleSynapz, if I want, I can create 2-layer, 3-layer. Nobody can stop me. But there's a cost involved, maintenance involved. I can create 2-layer architecture. Who can stop me? Right? But of course, my management will ask, why are you buying one more firewall? One is enough. I'll say, no, I have to protect. Where is the server to protect? One server is there. So to protect one server, why need two firewall? Okay, I'll have 5 servers. Okay, what is running on those 5? Okay, I'm running website. I'm running some, some information or logs and all, right? How critical are they? It's okay, not that critical. We are taking backup. So you don't need core firewall. Right? So that always, this is how the discussion happens. Is it clear? All of you guys?
Yes, sir.
I will show you
Yes,
one
sir.
infrastructure of a, see, this is our lab. I don't know. This is, can you guys see the screen?
Yes, sir.
Yes, sir.
Have you seen it before?
No, sir.
No, sir.
No, sir.
So this is our own product. So PurpleSynapz has a product also. This is a cyber simulation lab. Generally, it is used in SOC trainings, right? But the concept I can explain you. SOC is basically like, how do you protect an entire company? Company means everything. So many users are there. So many products are there. How do you protect it? in that sense, right? So on those training, we use our product, but this discussion, whatever we have had so far, you will be able to see that, yes, this is how a typical topology of a company looks like. Any big company will look something similar. Just loading, just wait for a moment.
Sir, one question what can I ask?
Can you see the screen?
Yes, sir.
Sir.
This is how a typical company's firewall will look like. Look at this. So our lab is also saying 2-layer firewall. So what is this firewall? It's a core or perimeter?
Parameters, sir.
Perimeter.
It's a perimeter. Why? Because it's towards the internet. Okay. And on this perimeter, I'm hosting my DMZ, all my website, officetime.com, stage.com, purplebank.com, videotube.bank. We are running some website for the internet people who are sitting on the internet to consume. And these servers are also connected to the database, which is in InfraLAN. And I have a core firewall. Core firewall is protecting these management and infra from my internal employees also. So if my internal employees machine is infected, it can infect my other servers also. So I have a rule base here. I have also rule base here. Is it clear? This is how a company will look like. They will have multiple zones, multiple LAN, user LAN, marketing team, sales team, Delhi team, Mumbai team. You will have all these things connecting to a common firewall. Then that firewall connected to here, right? But if you go to any big infrastructure, big company, now there is no only firewall. If you talk about any company which is having more than 1 lakh employees, so they will have a Delhi office, they will have Mumbai office, they will have Bangalore office, they will have USA office. Inside Delhi office, they will have one firewall, another firewall. In Bangalore office, they have one firewall, one more firewall, because there is some core servers are there. Here also there are some core servers. Then in Mumbai, you have only one server because less users, core server is not there. And suppose in USA also you have one server. And there are employees sitting here. In USA, in Mumbai also, you have employees sitting here. So when you get a topology diagram of any company, you will see all these devices, 4, 5, 6 firewalls in this. Correct? 6 firewall in this setup. But if a company is having 50 locations, so minimum how many firewalls will come? Guys, at least 50. Assuming that each location is having one firewall, correct?
Yes.
And those firewall will be connected to each other via VPN. Okay. There is a VPN connectivity between all these devices to each other. That's a VPN concept. Why? Because if this user wants to access this core machine, they should be able to go via VPN. This is not allowed for external people. Via VPN tunnel, reaches here, access that. That is why your job will be to make sure the configuration of this firewall is good, configuration of this firewall is good, rule base is good, VPN tunnel is properly up and configured and working nicely, so that these people are able to access this particular machine. If they will not be able to access it, they will raise a ticket and they will ask you that I'm sitting in Delhi trying to access a server in Bangalore, core server. Here is the IP address of a server called 20.20.1. My IP is 10.10.10.1 and my packet is not reaching. How will you troubleshoot? You start whether it is reaching the first firewall or not, whether the user is sitting. If it is not reaching here, What is the point of troubleshooting VPN and second firewall? Are you with me?
Yes, sir.
Yes, sir.
There's no point, correct? So troubleshooting also the common sense like to start from here, whether it is reaching the switch or not, layer at the physical layer, whether the LED is growing or not, whether the Wi-Fi it is connected or not, right? So you go one by one. That this firewall, you check whether it's reaching the firewall or not. Then if this firewall is working or not, do you really directly want to check in this device packet is not coming, or second step would be whether VPN tunnel is up or not. If tunnel is also up, packet is also reaching. Once the tunnel is up, inside whether rule is configured properly or not to allow, maybe the packet says drop. What is the default rule of any firewall? You just buy a new firewall, configure it very basic. What is the default rule?
Deny.
Allow all, drop all, what?
Implicit deny.
So by default,
Implicit deny.
deny.
By default deny. Everything is manually has to be created by the customer. What rule they want to create? Who will be allowed where? Which IP should be allowed where? So you guys have created rules, right?
Yes, sir.
So under source column, under source, what all I can enter as a source? I can enter IP address.
Source IP.
What else?
Source IP.
No.
Any.
I'm asking about source. In
Any.
source, I can address one IP address, one IP, which is also called host. Host means one single object, one IP. Then I can also type any. Very good. What else?
None.
Port.
No. I'm talking about source machine. Under source column, I can type any source, or I can type one host, basically one IP address. What else I can type?
None.
What? Can I enter network?
Range of IP.
Yes.
Yes, sir.
Can I type
Network.
network?
Network.
Network I can give 10.10.0.0/16. So anything starting with 10.10, it will be allowed. So network also I can use. Then range.
Range of IP.
Check. Range is anything starting with 10.10.10.1 till 50 is allowed. So under source column, I can type a single IP address, any network or range. Similarly, in destination, what all I can type? Same thing or different?
Host. Any. Same thing, sir.
Same. Exactly same thing I can put it in destination also. I can allow a single IP. I can allow anybody, like internet. When you give internet access to anybody, what will be the destination IP address? It will be any, right? Because you do not know which website this person is going to access. It can be network also. It can be range also. Destination site. Anything is fine. This is how you create a rule. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now let us take a short break, 10 minutes break, and let me see if I have a session or something. Yeah, I have another session. Let's do one thing. We'll catch up again tomorrow. Okay. And I'm noting down some of these points, or else we can catch up today also. Tomorrow, can we catch up at 10?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So let me note down the points which you guys have mentioned.
Sir, can I ask one question?
Yeah, go ahead.
So when a DSCP server is in another network and a client is in another network, so when a client requests for a DSCP configuration for IP address, so will it be successful?
Come again. Can you repeat your question again? Yeah, Raman.
So a client is in different network and a DSCP server is in different network.
Correct.
If a client is trying to request for a DSCP configuration for IP address subnet, so will it be
Correct.
get?
Okay. So what is your question? Raman, what is your question?
So my question is, so a client is a different network and a DSCP server is in different network.
Okay, so suppose this is the client. Can you see the screen?
Yes, it is visible.
Yes, sir.
Machines are generally connected in switch, in almost all organizations, or there will be if it is on Wi-Fi, right? And this Wi-Fi device will be connected to a switch. And you are on Wi-Fi, or else you are directly connected on switch. This is how it. Any company, if you go, this is how it will be. Okay, and this will be connected to a router. So if this is your infrastructure for a LAN, and this router may be connected to another router, and on that router, you have a centralized DHCP server. This happens when small branches are there in a company. Like the company is very big, but their offices are very all their offices are very small, right? So in their local office, they do not want to maintain a DHCP server or DNS server, whatever. Why? Overhead. Who will maintain? Not working. I get a different IP address. This is not working. Who gets the which IP address, right? Yesterday it was working. Today it is not working. And you have no idea who is using what. Correct? In a small organization. And you do not have any control in the small, location. What companies will do is they will not use local DHCP. They will ask you to create a normal client, and the settings would be settings on those machines will be get IP automatically. You guys have seen it in your Windows setting?
Yes, sir.
Let me share my screen full screen.
Sir, what is the function of DHCP relay?
Yeah, that's what I'm telling. I'm just going to that. Okay. Can you see the screen?
Yes, sir. It is visible.
So if you go to Ethernet or any of your network card, generally all of you guys, there are two ways to configure IP address. One is you configure manually, go to properties, go to TCP IP4, right? Look here, obtain an IP address automatically. So I'm not configuring it. Somebody is giving me that IP, and with that I'm working fine. In my case and your case also, it is my Wi-Fi router giving me the IP. So my Wi-Fi router is a DHCP server. The question was, right? So here in case of Wi-Fi, and you have a DHCP here. So you broadcast the packet. The process is DORA, right? This you have already studied, correct? My old video you can refer.
Right, sir.
Midterm
Yes,
one.
yes.
Okay, you get a DORA. Discover means what? You broadcast everybody asking who is DHCP, who is DHCP, and the actual DHCP will reply, I am DHCP. Then you ask, okay, can you give me IP address? And then it will, yes, take this IP. Initial packet is discovering who is DHCP here. Why I am discovering? Because my setting says obtain IP automatically. Now the question is, in the big companies where they want to have a control of IP addresses, it is not sitting locally. It is sitting somewhere remotely. So in that case, the concept of DHCP relays is used. So DHCP relay is on this machine, on this router, because all your DHCP packet. So DHCP discover packet is a unicast or it's a broadcast?
Sir, DHCP relay will unicast packet to DHCP server.
No, the first packet for the DHCP,
It will
is
be
it a unicast packet? Broadcast, no, because you do not have any IP address. You do not have any IP address, right? You do not have any configuration, any IP address. You will just broadcast. When you broadcast, everybody will receive the packet. Everybody will receive, including this interface, which is facing towards you, your LAN. You will receive it packet here. But if you don't do the proper configuration, or when it is not required to run a relay, it is normal configuration, default configuration says don't do anything. Don't react on broadcast packets. Any broadcast you receive, just ignore it as if nothing has happened. But when you configure DHCP relay, why I'm configuring? Because in my company, my DHCP server is here in somewhere else, maybe in a different location, maybe in a different floor. First floor is people are sitting. My server room is in third floor and DHCP server in third floor. And there are routers in between. So question is, routers are in between, not switches. If everything is connected via switches, switches will handle the broadcast. When there is a router in between, layer 3 device, then you will receive this packet here and you have to make a DHCP relay configuration so that it will capture that DHCP relay request packet. It will capture that packet and top of it, it will add its own layer. Okay. And send it till this interface, because it is configured here that DHCP relay should send the packet to this DHCP machine network. So this is the original packet, red wala component, absolute original packet, which is being received by everybody. Right? Everybody is receiving this. So this also received this packet, but whatever it will do because of the DHCP relay concept, it will create a layer on top of it and hand over this packet here. In the original same format. And obviously when it receives the packet, it will believe as if I am sitting here. I received it. Now it will send a reply packet. Discovery has happened. Offer. So that offer packet is again, this router will take care and take it back to the device. So this communication, whatever is happening, this is happening because of DHCP relay configuration. If you have to do DHCP relay configuration, router supports DHCP relay. Firewall supports DHCP relay. What is the meaning of DHCP relay is, if broadcast packet for DHCP is received, I can take that packet, and if you tell me where to drop that packet, I will do it for you, so that it reaches the destination. So this becomes the actual packet. And now this packet as a whole with IP layer, source IP, destination IP, just like a regular, like now it is taken over to the destination. Because you cannot say I am DHCP. I am running as a DHCP relay. No, you cannot say I am DHCP relay. It's not allowed. You have to say I am DHCP relay for A.P.C.D. For this IP, I am relaying it. So this is an IP address. This is your DHCP configuration. Is it clear? That configuration. Otherwise, this is lost. How does it know where to send the packet? Yes, clear?
Yes, sir.
What is ARP?
Yes, sir.
Any questions on that?
Sir, what is ARP? ARP?
If the DHP is down,
You
then
watch
what
my
will happen?
videos, midterm videos, you watch, and ARP and everything I have already configured, told you. Okay, go ahead.
Sir, if the DHCP is down, then what will happen?
You will not get the IP address. Okay. If the DHCP is down, you will not get the IP address. And if you do not get the IP address, you can check on your own. You can check on your own laptop. If any interface doesn't have an IP address, they generally get an IP address called some dummy IP address. You will configure 169, starting with 169.
Apipa IP.
Apipa IP, sir.
What is called?
Apipa IP. sir.
Apipa IP.
Apipa IP. That is called
Automatic
Apipa
private IP
Yes.
address.
Yes. So I'll show you that. If nothing is there, check here. In my computer also, when I'm checking my own IP address in my computer, I have a lot of interface card for VMware and all. This is my actual Wi-Fi. This is fine. Look at this. One more interface is there. Nothing is configured. DHCP is not working fine. By default, it has picked up this IP. I think this will be same for everybody. This IP is called Apipa IP.
Yes, sir.
But this is totally meaningless. It is of no use. It just gives you something. It means nothing. So try to ping. It is pinging. It's a local. But it means nothing. Sometimes it is used for the programming reasons, because when you programmer write a code, they need some kind of IP addresses. Okay. Just give me a moment. Just a second. Okay. You guys have Apipa IP address on your computer? Clear? So DHCP request goes to the router. DHCP request goes to another router, and finally reaches to the server, and server will make the offer. Okay. And request packet is inside a packet whose source IP is 10.0.0.1, destination is 50.0.0.10. 50.0.0.10 is your DHCP server. And once it reaches the router, again it releases the same packet back to the source machine, and source machine will have no idea that actually my DHCP server is far away and so many routers are in between. The way DHCP server will have no idea that client is not sitting next to me, but the request is coming from far away. Is it clear?
Yes, sir.
Can you raise your hand or thumbs up or like no reactions is there quickly? All of you are there, not there. Quickly raise your hand.
DHCP server is in subnetwork.
Okay. Ask the question again.
So DHCP server is in the subnetwork, or it is in the different network.
It will be on a different network. When the moment router is in between, it has to be different network, because router divides the network, right? Concept is routers divides the infrastructure, right? Router is a layer 3 device, correct? So router is a layer 3 device, means if you have a router and it is having this interface, forget about router, even the firewall is also a layer 4 and above device, but that also means it is a layer 3. So on this interface, if you are configuring an IP address called 10.10.10.1 and subnet mask, you want to give it as 255.255.0. This also means what? Slash
24.
24.
Correct? 24. 8 plus 8 plus 8. The moment you configure, this is the IP address 10.10.10.1. The moment you log into the same router and configure the interface of this IP as 10.10.10.1/24 or /8 or /23, this will never allow you to do that. You'll get an error. Okay.
Yes.
Because the IP is same, it will give you duplicate IP. How can in the same device have two IP addresses? 10.10.10.1, 10.10.1. But next logical question. Can I configure an IP address on this interface on a router 10.10.10.2/24? Can I configure it?
Yes, sir.
Mention in the chat, yes, no. Who says yes? Mention in the chat. Can I configure 10.10.10.2 on this interface /24? And here it is 10.10.10.1/24.
So we can't configure the same network on two interfaces.
Don't raise your hand. Who think you can configure it? Raise your hand. Those who think it can be configured, please raise your hand. So we have Ankit raised the hand. Then no, Reet is there. She's raising hand. Nirmalaya is there. You have removed the hand. What is this? So now we are left with Arushi, Rohit, Kapil, Seema, and Subrata and Amir Hussain, who believe that Visheshwar also, who believe that yes, on a router, if one interface of a router we can configure as 10.10.10.1, we can configure 10.10.2 on the same router, and both are having the same subnet. Okay. So I think somebody was asking about subnetting. You should watch my video again, that which I explained in the midterm. When you configure any IP address, is absolutely okay. You can configure whatever you like. The moment you type this subnet mask /24, /8, whatever, or other form of representing 24 is this 255, 255, 255. How will you represent /8?
255.0.0.
Correct. This is the other way of representing 8 into that, right? The moment you attach this knowledge, what basically you are saying is 10.10.10.1. Okay. And the most common subnet is generally 24, sometimes 8, but most common is 24. So we will assume 255, 255, 255.0. When you attach this subnet on top of this IP, basically you are saying that leave this. This part, this part, and this part has to be same for same network. If I have to call it as a same network, I have to give these three as same. This can be anything dynamic because it's 0 here. And I have to use this same subnet. When I'm doing this, with this logic, these three has to be same. Subnet mask has to be the same. Then whatever I'm getting the IP address, I'm calling it as the same LAN or same network. So 10.10.10.5, 255, 255, 255.0. Does this belong to the same network as this or other?
Same network.
Tell me.
Same.
Same network.
The network is same. Subnetting is also same.
Correct. This IP address, once you put a subnet mask, see when you do not put subnet mask, you will never be able to know what is the network of this IP. If I just tell you random IP 49.10.1.5, just random, I'll ask you what is the subnet mask? What will be the subnet mask of this? What?
It will depend upon the
255.0.0.0. So because
Why?
it's belonging class A.
Why?
So it's because class A ranges from 1 to 127.
Correct. So that is
the first octet.
So this is a theoretical answer that by default class A IP address will have default subnet mask of this, but this is only theoretical. By looking at IP address alone, the answer is absolutely capital no way to find out the subnet mask or the network part. There is absolutely no way by looking at the IP. Only when you attach a subnet mask to an IP, that time you will get what is the network and what is my host part. So in this case, this is my host part. Why my host part? Because whatever is network, remaining is host. This is network. Why network? Because of the subnet mask. The subnet mask, the first three cannot change. If cannot change, this is my network. So what is my network ID? 10.10.10.0. Last time we put 0. This is my network. And what is my host ID? Host means one IP address for a single computer. So you have to give this IP address a .1, .2, .3. And what is the subnet mask? You put subnet mask here. With this logic, this interface, this cable, because it's a single cable, single port, it connects to one switch. Anything starts with 10.1, 10.10.1, and it goes up to 254. Should be on this side. This is what you are telling to the router, that I am giving you this IP 10.10.10.1 and I am giving you this subnet mask. This means anybody .2, .3, .4, .5 till 254 should come and hit you here. It is on this side. With this logic, if you put 10.10.10.2, it is actually overlapping with this. At one side, you are telling entire network is here. Other side, you are configuring .2, router is confused. And router will give an error. And technically also you should never configure it. Otherwise, computer will always be confused. Because as per this configuration, anything related to 10.10.10, 10.10.10.x, anything is on this interface link. So all other computers should be here on this side. This is called creating a network. Subnetting is a concept of, again, it's a networking concept itself, but dividing a network into smaller chunks, smaller network is called subnetting. Somebody was asking that question. So you can watch that video, but for in this example itself, I'll quickly go through it. If you have to divide this network 10.10.10.0 into equal networks, so then what you will do, you will do 10.10.10.0. Here you will put 255.255.255 dot. You have to put one bit here. So you put 100. So basically it means 127, 128. If you use the word 128 means this one bit is gone to the network side. So you cannot change that. So basically in decimal format, it is 10.10.10 0. Obviously, see lot many types you have to go from decimal to binary, binary to decimal. So you have to be little used to it. There are softwares also available, but from the knowledge perspective, 0 represented in bits format is this. 4 times and again 4 times. 8 times 0 is called 0 here, this 0. 128 bit is basically says 255 means 111111111. 1111. If you add it, these are all 11111. 8 times. This 128 means this one, and rest everything is 0. So what you did is sorry, till this level you are telling it's a network. I cannot change. Rest everything is changeable. So if this is fixed, this is changeable. So it will change from where? It will start with 000 is 1. 0001, it's 1 IP address, 2 IP address, 3, 4, 5, 6. It can go up to 128, 127. 128 is network. And 129 and above will become part of a next network. So this is network 1, where this is the IP. First IP would be 10.1. Network address is 10.10.0. Subnet mask is 255.255.128. The moment you attach subnet mask, it defines what is your boundaries. So if I put this is my boundary, in this boundary, I have 1 till 126 IP addresses. 127 is what is 127? It's a broadcast IP of this network, and 128 and above you can take it for the next IP addresses. So your next network would be 10, 10, 10, 128. Is a network part. First IP address of this network would be 10, 10, 10.129, and subnet mask remains the same. Okay. So this IP in this network and this IP in this network, both are same or different? Are they belonging to same network or different network? Any? Guys, it is same or different? If it is same, raise your hand. If it is different, you raise your hand. If it is different, raise your hand. It is different, and since it's a different network, I will be able to configure it here. 1 as 1, but my subnet will be 25 now because of this 1 bit which has been taken over here. So now it becomes 25, 1 or maybe 129, and this will become 1 with subnet mask as 25. So this is allowed in the router because this configuration says that from 1 till 126 is here. After that, I don't know what it is. This configuration says from 129 till 254 is here. So both are different. Both are different network. I hope this concept is clear now.
Yes, sir.
OK, good. So now let me go back to the chat message. Gateway in the firewall is basically This is very theoretical. Maybe on the internet you must have seen it. What is the difference between gateway and the firewall? Gateway and the firewall is the same. Sometimes router can work as a gateway. Gateway is a network device which connects two different networks. So router can also work as a gateway. Firewall can also work as a gateway. Okay, this is very theoretical question on the internet is filled with. I don't think so any normal guy will ask this question. Gateway and firewall. Okay. Firewall is also a gateway. Gateway is basically a device which sits between two network and it processes the packet and moves the data from one network to another. And when the return packet is coming, it is handed over. The same job is done by router. Same job is done by also by the firewall. It receives the packet, process it, but it also uses logic rules, what is allowed, what is not allowed, and drop the packet and then send it to the outside. So firewall is also used as a firewall gateway. If you go to the internet, if you use the word firewall gateway, it's quite common. People using firewall gateway as a word. If you go to Google and type firewall gateway, you'll find the, this link coming over there. See here. What is this? Firewall gateway is also coming as a device. Now somebody has given you this difference of what is the difference between gateway and a firewall. Let's open it up and then try to understand. Gateway is a networking device. So basically a router that regulates the network traffic between two network. Router is also a gateway. Can you see here? Receives the signal at one end, send it from the other. Firewall is little more advanced gateway because it filters also the packet, which I told you earlier. That's it. This is good enough definition. That's it. Don't go too much into detail. Okay. Router is a gateway. So can you see the screen?
Yes, sir.
So you have one computer and then you have a router, okay, or a switch. It could be anything. And there is a cable connected in between, right? You have a cable. Mostly this logic is in cable network. Nowadays everything is full duplex, okay? And you have cable connected between these two. Half duplex means that only one machine can send the data at a time. When I am sending the data, this machine cannot send me back any data. Half duplex means one at a time. That concept is called half duplex. So if a device is configured to work in half duplex, other side also has to be half duplex. That is number one. If this is full duplex, this also has to be configured as full duplex. It cannot happen like that one is half duplex, other is full duplex. The logic of half duplex is like when it is configured as half duplex, your speed will be increased or it will be decreased. Tell me.
Decreased, sir.
It will be decreased because when you are accessing YouTube or any other data and you are receiving the data at the same time, right? You are receiving the data at the same time. Both should happen at the same time from this cable. In this cable, you should receive and you should be able to upload both. That is called full duplex. Half duplex is only one device is allowed to send the data at the same time. Now this generally in the old days, there was a hardware called hub, which is not there right now, but a lot of people still ask questions in the interview. Not many, it is just dying away because that concept is no more required. But when you have two PCs connected via hub, not like switch and router, only one device will be able to send the data at a time. And then there is a router, suppose router. And from router, there is an internet. If two devices are connected via hub, only one device will be able to send that data. This device will send the data. This will not be able to receive. Why? Because this hub will broadcast the packets here. If I'm sending it, all packet received by everybody. So you don't need a hacker. So everybody is a hacker. So if you all are sitting in the same office and we are all connected via hub, we all can see who is accessing what. Okay, which is obviously not required. And since everybody receives everything, like when I'm receiving, I cannot send the data. Okay, just a moment, just hold on for a moment. So HA is basically high availability concept where from the business perspective, how it is done. I'll answer you the why part. How do you know where to click, what to click, how to achieve it, right? But concept wise, you have a sender and then you have a receiver. And then you have some intermediate device in between. This device can be firewall, this can be a router, this can be a load balancer, right? Citrix or whatever. If you have only one firewall or one device only. So far we have discussed that yes, there's a firewall rule is there. Just imagine in the real world. There's only one firewall, right? This is the hardware, end of the day, it's a hardware. This will fail. Hang. It will crash. Not booting up. It powered off, it automatically restarted. It's not working anymore. Entire office will be down. Nobody will be able to send any traffic via this device. That is why most of the company, very small companies, again, cost is the issue. Not they do not want. Cost is the problem. As a backup, high availability is basically a backup concept. So you have another layer of device which you will add it in this equation. Come again. Somebody saying something? So this is device 1. This is becomes device 2. Some companies people put device 3 as well because they believe like if I need to take a high availability when 2 hardware fails, and it fails by the way. Okay, remember that. So when you are working on your client, you will always say there are 2 firewalls. Most of the places, very less critical office, less critical team, they will have only 1 firewall. Okay, that means that your job is dependent on the firewall. So when you configure this in the HA, this device needs to talk to both the device. At that time, you create a virtual IP because physical IP, if it is this is physical IP, this is physical IP. Because 2 devices, 2 different. This is also a physical IP. The other side is a physical IP. Now, when this machine has to send, it cannot send directly to this or this. So what you will configure is you will configure a virtual IP. You say HA or cluster, both are same. Okay, HA, clustering, both are same. So you create one virtual IP. This is the concept of this device. This device supports this. This user has no idea, no issues. It has no idea where I'm doing, what I'm doing, whether it's an HA, VIP. It has no idea whether the HA is there, not there. They have no idea. Sender and receiver have no idea. This device supports HA configuration. And in HA settings, you do this configuration. What is my virtual IP? What is my virtual IP? What basically this device is, if my physical IP is 10.10.10.99 and this physical IP is 10.10.10.100, then what both are configured together to tell each other that virtual IP is 10.10.10.101. So this machine will send data to 101 and it will be received by active device and there will be standby device. So for HA, there are 2 modes, right? Active standby and then active. So depending upon what the product supports generally, right? So one will be active. That means anybody sending any packet to 101 means 99 is handling the packet, process it, send the packet outside, and the other side is also true. So other side is 20.20.99 and here it is 20.100. Virtual IP is you configure as you can configure whatever you like 101. So this receiver will send the packet to 20.101 processed by this one because this is active. Everything goes like that. The moment this device is down, This goes down, right? Immediately this machine will come to know. Why? Because there is also connectivity between these two, and both are monitoring each other by sending a hello packet to each other. But that concept we will not go detail because this depends upon different products, how they are configured. But the idea is both are sending, hello packets to each other, right?
Sync network.
Come again?
Sync network.
It's a sync network is for different for syncing the table, connection table, right? I discussed you today. So that table is synced between these two. Because this table is having that entry, that table is also pushed here. So that when this is down and nothing should be interrupted, right? So when this packet comes, right? Entry is already there and this becomes active. When this becomes active, it will tell other devices that please change your ARP entries at the layer 2, right? Because in your entry because for this device, the IP is 20.101, which is a virtual IP. Map to a MAC address, which is of active device. Or sometimes the configuration will say you can create a virtual MAC address also. But this has to change because this device does not exist anymore. So this device, once it becomes active, it will announce and tell everybody nearby devices to please change your MAC address. Keep the IP same, but MAC address should be changed to now my IP, whatever I am giving you. And then rest of the things continue. This is called high availability in active standby. In case of active, both will receive the packet. Both will talk to each other that I will process this packet, you will process the another packet. When the return packet is coming, the return packet will be processed by this machine. The one which is processed, the other one will be processed by this. Both are handling the packet at the same time. Half of the connection now the logic of who will access which one. The default configuration says round robin. Is the word which is used. Round robin means first packet you will process, second I will process. Third you will process, fourth I will process. Connection basic, not packet. Because packet will be random, then will confuse, right? Connection for particular source to particular destination to particular port, I will access it. I will, but the same destination, but by a different user, you will handle it. So round robin, 1 year, 1 year, 1 year, so that the utilization of both the hardware is managed properly. Is it clear?
Yes, sir.
So this is called the concept of high availability. Different product work. How high availability is configured in Citrix versus Fortinet versus PAN versus Cisco versus Checkpoint. That's a different concept. Little bit if you have done the lab, just go and revise it. That is more than enough. Don't learn anything new. But the high availability mode works like this. Okay, one is active, another is not active. So in high availability mode also, it says like I will explain that active firewall will always be processed, right? You have at home, you have primary phone or secondary phone, right? You use this phone all the time. Maybe the phone numbers are synced because you have a same Android phone, Google account is same, right? That is called connection table. Both have the same data. Maybe the last called digit, last received, it will not be there. It is not synced into that, but phone number, phone bank is saved. This you are accessing it, using it all the time. But now this phone is damaged, it's not used, lost it, you'll start using it. And communication still continues. Right? But in the hardware world, you have two devices. You configure it as per the configuration that how I am active, I am standby, both agree to a point, configure a virtual IP address on both the sides, internal and external, so that other parties don't think like what is active, what is standby, because they don't care. What is active standby? They just want to send the data. Receiver is sent through data, right? So that logic is being taken care by the active and standby devices. And both can work in active and standby. Another can have active and active. In case of active and active, both will process the packet based on route drop-in. And this route drop-in is not per packet based. Generally, it is per connection. What do you mean by connection? It's a connection is a combination of source IP, destination IP, source port, destination port. It's a one combo. So so long as this is same, this will process. Anything is changed, other will process. And this is how they will keep having a track of who will process which packet. I hope it is clear now. What else? Supposed to work at the same time. Okay, then one firewall disconnects. How to work second firewall same data? I'm not getting this, Kapil. So suppose two firewall connect at the same time. One firewall disconnects. How to work second firewall same data? So firewall will work because firewall has been configured to work in an HA. While you're doing the configuration, you have already have a setting. This is firewall 1, firewall 2. While doing the configuration, when you go to the configuration page, you are telling who is your peer next device. And you have to work all these devices for the external user will behave like a cluster. They will not see any difference here, sender or receiver. They all will believe it is coming from a same device. Internally, they are syncing to each other, talking to each other. Okay, checking whether who is active, who is not, because it has to automatically happen. When this box is crashed, this does not even have time to tell that I am crashing. This will, when it's crashed, it just crash in a moment, right? It will never tell that as okay, I'm getting down now, you take over. That never happens, right? Clustering is not configured with that concept. So this device has to continuously monitor health of each other. So if I stop getting the health report or a hello, response packet, right, from the other firewall, when checking the health of that, if I don't receive, configuration in the firewall by default will say, okay, wait for 5 seconds. And within 5 seconds, if you do not get, you consider this firewall is down and you announce that you are active and tell everybody else to send the packet to you directly. So in case of active, right, when you send the packet, it will not be handled because it is down. Anyway, all the packet is received by both the firewalls. It's all about who will process. It's not like I'm sending the packet here, I'm sending the packet here. Then I am doing the job of HA. So I don't want to do any job of HA. I will send one packet. Both will be received. We receive the packet. One will process, another will discard. But based on the mutual communication. But once it is down, packet is anyway, I'm receiving it. I will also start processing it because I know the other person is down. I am the only active member. Is it clear? Kapil? Is concept clear? Transport mode, and what is the other mode? This is a concept which is used transparent mode. FortiGate is what it uses. Is almost all firewall support. Checkpoint also supports it. Transparent mode means I behave like a switch. I will receive the packet because I have NIC cards enabled. but I do not have any IP address. So the word transparent. Okay. So generally what happens, whatever you guys have learned, and almost everywhere, transparent firewall, you will find it very rare. It's very rare that you will find a transparent firewall. But generally, if you have a firewall, this IP address would be 10.1. The firewall's internal interface IP would be 10.100. And the default gateway of this IP would be 10.100, correct? Because it has to send all the packets to the firewall. Reverse is also, other side is different. Suppose like it is 20.100. And this device, the IP address is 20.1, for example. So this is not transparent mode. Then everybody knows that there is a firewall which exists. Now, when I am sending from here to here, I know there is a device intermediate which is sitting in between, and I have to process through it, and this process will receive. Now, in some situations, you do not want to put an IP address in between. Why? Because in that case, because your server, the other side of the server, is also coming from the same network. So same network means this is 10.1/24, suppose. So the IP address of the other device is 10.2/24. Both belonging to the same LAN. And customer says, absolutely, I want to buy firewall. I want to use firewall also, but my network is so complicated that I do not want to change anything here, neither here. I do not want to change. Do you have a product to support this? Then companies which support transparent mode will come and sell their product. Yes, I have a product. Don't worry about it. I don't need any IP address. You just take this cable here, connect here, and take out this cable and connect here. Okay. So earlier you had a switch. Via switch, you both were connected, talking to each other. No security. Now you remove this cable from here. You directly connect here so that everything goes through this device. Now in transparent mode, when I configure, I do not configure any IP here. So this machine will never come to know that there is something in between processing me, because it's a 10.1. When it sends an ARP request, who is 10.2? It's a broadcast. It'll come here. It will go here. It will receive. It will send the packet back, and both are talking to each other. Firewall rule is still applied. If firewall rule says 10.1 cannot access 10.2, when you are sending the packet, this packet will be dropped. This configuration settings of a firewall where you do not configure an IP address on the NIC cards, but still apply the security rules, is this called transparent mode. Why transparent? Because from this perspective, sender and receiver perspective, they do not believe there is something sitting in between. Just basically working like a switch. In switch also, like now you do not know who all is connected because there's no routing device. Anybody can talk to anyone, right? You don't need any permission. The firewall also sits like that. That's called transparent. I hope it is clear. Neet, you want to add anything, Neet?
No, sir, it's fine. Sir, one more question.
Yeah.
Sir, after the establishment of the TCP connection, like after 3 packets is confirmed that TCP connection is built, and the 4th packet is sent, then what response should we get from the server side? Like after establishment of the connection, which flag would be provided?
Which flag will be used?
Yes, sir, like
acknowledgement.
yes,
You always acknowledge.
Only we
Yes.
should acknowledge the things. Like if I am
Correct.
sending the 4th packet, then after sending a fourth packet, one acknowledgement flag would be shown. Then fifth, then acknowledgement.
Right. So let me capture the packet right away and I'll tell you how to access it. Suppose let me take some old data I had, okay, and let us see here. So sync some packet over there, right? You start the connection, sync acknowledgement, right? Then you send push when you are putting any data on top of the server, right? And you get acknowledgement. Acknowledgement. All the TCP packets or after that will have the acknowledgement bit set. Okay, in flags. Acknowledgement means I am sending you acknowledgement packet for this sequence number. Okay. So
the
when you are
data is
sending,
been received.
You will look at these numbers also. Sequence number, acknowledgement. Right?
Yes, sir.
Sequence, acknowledgement. Sequence means I am sending you this packet. I am acknowledging your packet. Acknowledgement means your packet. Sequence is my packet.
So basically
Okay.
confirmation of the data that has been received.
Correct. So look at here. So acknowledgement sequence number is 697. One machine is sending. It is sending too many packets at one shot, right? So I got 697 is my sequence number. Apart from 697, I am also sending you 1460 packet more. Right?
Yes.
So my sequence number is 697 and length of the packet is 1460. So apart from this sequence, this is the packet which I've sent it to you. I am also sending 1460 to you. So my next sequence number will be this 2157 here. My sequence number, the same sender, it cannot change. And since with now I'm sending 2157. Along with that, again, I'm sending you 1460. You add one more 1460, you get this sequence number. You keep sending it this sequence number. Server is not responding. That is why acknowledgement number is 1. The moment server will reply, even this is also a client. This is also a client. This is also a client. So much of data it has uploaded because this packet which I have captured is a file upload. I am uploading. The client is sending data continuously. Finally, after so much of data is received, up to what level it will continue to receive? It is unlimited. Who decides up to what level it can keep on sending? Window size. Correct? This window size decide that yes, it can without even replying any acknowledgement packet, I can keep receiving the packet. Look here, I was uploading a file. First packet, second packet, third packet, fourth packet. So basically my TCP header has divided my image file, which I am sending it here, into 1460 bytes. I'm sending it. Finally here, server says my sequence number is 1. So this is my first packet. And I am acknowledging till 1597. So 1387. So 1387 plus 1460. That is the last packet, right? This is the number. Sorry, not 13. It is 13837. 13837. That was the sequence number. Can you see here? In this sequence, I am also adding 1460 more. So 15297. Can you see here? 152. So server is saying I am acknowledging 15297. I have received successfully. No issues. All these packets are good. 1, 2, 3, 4, 5, 6, 7, 8. Rather than sending acknowledgement for every damn packet. And my sequence is first. That this is my first packet. Correct? Go here. Then you send more acknowledgement. Who is sending it? This is again client is sending more packet. After that again 1460. Then again it is acknowledging to one more time. So this is how continuously happen. But if you go a little bit more, server sequence number will also change. If it is sending some packet. Like this is your server. Because if it is not sending, still the sequence number is 1. Can you see here? My length is 0. So server is not sending any packet. Server is just acknowledging it. You send me, okay. Send me, okay. You're sending the packet to me, okay. Are you guys getting what I'm saying?
Yes, sir.
So length is 0. So my sequence number from server will never change because I never send any packet. I'm just acknowledging it. What is in the acknowledgement? See, acknowledgement bit is set. For what? That I received 59471 packets from you. I'm acknowledging that. But my sequence is still 1 because I am not sending any packet. My length is still 0. Now, if you put now, if you look at this is the sender, look at the acknowledgement sequence number. It's always 1. But imagine now exercise for both of you guys, those who are asking the question. If you access any HTTPS website, when you are accessing YouTube, for example, so you are typing the query, what video I want to watch. That is you uploading it, you sending the data, right? So your sequence number will change when you are sending the packet. YouTube is sending the packet to you because it is sending, video to you. So YouTube sequence number will also change. So both sequence number you will see increasing. Who is sending more packet? So simply looking at this packet clearly tells that 221 is sequence number 1. That this machine is only sending the packet because its serial number is 1. It is just acknowledging it. It is basically receiving it. 35.1 is the machine which is actually the machine which is taking the file, uploading it basically. I'm uploading the file. So this is this packet belongs to this machine. This is doing the job of uploading. I am not sending it back. I'm only receiving it. So 35.1 has sent up to 50,000 bytes or a packet for which server is acknowledging it, and server has sent only 1 packet. So when you do HTTPS communication on YouTube and all, don't do it on Chrome because Chrome will use the quick protocol. Use Firefox, which doesn't use quick, or maybe Edge, or any other website for that matter, where you are also typing something. So you're sending the data and you are also receiving the data from the other side. You will see the sequence number getting increased. Is it clear?
Yes.
Is concept clear?
Yes, sir.
The TCP will start with the application layer protocol. TCP will start with the application layer protocol packet associated with that TCP packet. What is this question, Sriya? What is port forwarding? How it works? So Sriyanj, your question is answered or you have a different question? Port forwarding we will discuss tomorrow. I'm just taking a note. So tomorrow we will discuss SSL in depth. Okay, and port forwarding, which I picked it here. Shreyans has already got it. So application layer is HTTP. I told you already. You watch my, the midterm videos. When it has to communicate to other computer, it has to leave this computer and go to another computer. It has to use something on the transport. So it will choose whether TCP or UDP. It is already designed. So it is TCP, right? And TCP will hand it over to network layer. Network layer will be handing over to everything else. So that is how generally it works. Port forwarding has nothing to do with legal and authority. It's a technical requirement. Even our router supports port forwarding. My office router supports port forwarding. I have configured it. Nothing to do with legal and all. In what context you are asking, that we can discuss tomorrow. Okay, so I'll see you guys tomorrow. I think it's enough of today. I hope you. So how was your session now? Any feedback, quick comments?
Very good, sir. Very informative.
Okay.
We had a lot of doubts, sir.
So only Pallab has a doubt and got clear. Others are okay. So watch this video. I'll ask Sharik to upload it. Watch that initial stuff. See, fundamental always you have to keep in mind. Always keep in mind the fundamentals, because this is where the packet is going. You have never seen it, because the question, the moment you told that 10 10 10 1 I can configure here and 10 10 2 I can configure on the other interface, that clearly shows that there is some gap, serious gap in the fundamental understanding. How this subnetting happens, why this device will allow you to configure it. Because literally you are saying on the router, two interfaces belonging to the same network. Then what is the use? Right? Router is there to segregate network, and so that it can inter-network communication is done via router. If router itself will say I'm confused, I'm telling one side I'm 10.0 is this, 10.0 is that also, it will never be able to process. Okay, so revise it, note it down, discuss with that. Product specific skill set, guys, I would suggest 10, 20 times repeat it, the same thing, repeat it. By the time you exactly in the like now you're closing your eyes, you know where to click to configure object, where to click to create object. Don't think like creating object and natting I have done once and it has worked, so no need to practice it. You do it. Can you do it in 5 minutes? Is a question. Can you spin a new VM? Configure from the scratch. Suppose it took 2 hours for you for the first day. Next day 1.5 hours. Can you do it in 30 minutes? Is the question. Do it multiple times. Okay, because that is more of a practice question, right? Because that's not a technical part. This is what we are discussing is the technical, high availability. What is the logic? Why it is used? I told you, right? Any company, serious company, big companies will have high availability. Two machines club.